Yep. So, got an easier day today. We're going to be estimating integrals using semicircles, quarter circles, rectangles, triangles, and trapezoids. More importantly, we'll be talking about the meaning of these integrals and derivatives in context again. So I'm going to start out with this function of my robotic vacuum cleaner. So I've just picked up this robotic vacuum cleaner. It is not a smart vacuum cleaner, so it just kind of bounces all over the place. Whenever it hits a wall, it comes back. So I've got this function here showing me the velocity of the vacuum cleaner at any time. When this velocity is negative, that just means it's coming back to me. So this is as it's traveling away from me and then coming back to me. From quarter two, if we derive displacement, we get velocity. If I derive velocity, I get acceleration. And if I derive acceleration, I get jerk. Which also means that if we work backwards, if I integrate jerk, I'll get acceleration. If I integrate acceleration, I'll get velocity. And if I integrate velocity, I'll get displacement. Those are all vector quantities, which means they have magnitude and direction. If I wanted to go to a scalar quantity, then I could integrate an absolute value instead. So I could say something like this. The integral of the absolute value of our velocity in terms of time would be equal to our scalar distance, or total distance traveled. If you just integrate velocity without the absolute value, so if you just do this, then you'll get displacement. Okay, we talked about an example that looked something like this in quarter two. So if we had a house and a basketball court, and something else, so we'll say a restaurant. Okay, if we start from home, go to basketball, and then go to the store. What's our total distance traveled? $25, okay. But what would our displacement be? Okay, so our total distance traveled, if we did this, would be 25 kilometers, but our displacement would only be 15 kilometers. Your displacement measures your distance from a start point. So at the end of traveling down the green and the red lines, our distance from the start point our distance from the start point is still only 15 kilometers. So that would be displacement. Our total distance traveled, though, would be 25. So if we're trying to find displacement using our integration, then all of the signs will matter because we want the positives and the negatives to cancel out to figure out how far away we are from a start point. But if we're looking at total distance traveled, then I don't want the signs to matter. So anything negative, we'll have to make it positive before we add. Okay, so here's what that'll look like. So I've got our velocity here. If I wanted to integrate, I can break this up into areas. Which I'm going to break up further. Okay, on this left side here, I've got a 2 by 3 triangle, so this area is 3 units. On this trapezoid, I've got a 2 by 3 by 1 trapezoid, so this is 2.5 units. Okay, this is the most interesting one here, but if I box this in, this whole box would have an area of 4 units. This white space here is 1/4 of a circle with a radius of 2. So if I have a circle with a radius of 2, my whole area would be expected to be 4 pi. That's pi r squared. Pi times 2 squared is 4 pi. 1/4 of that is just pi. So that means this pink area is really 4 minus pi. Okay. And this blue area is a 2 by 4. So this is 4 units. And it is negative because we are below the curve. And then the same thing for this yellow space. 4 units below the curve. Okay, my pen's a little bit broken, so I'm getting some extra lines here, but can you guys still read? Okay, cool. So if I want to find the total distance traveled in the first 5 minutes, total distance means we're going to integrate velocity, that's step up, so we're looking at area, not slope. Up is integration, which is area. Down is derivation, which is slope. Okay, so I'm going up from velocity to distance, so this means I'm looking at areas. If I'm looking for the total distance traveled, then any negative areas will need to become positive. Anytime you go diagonally, you'll need to take an absolute value. If you go straight up, so that means your directions matter, and then we need to keep our signs. Alright, so if I want the total distance traveled in the first 5 minutes, I'm going to add these areas together. So this is 3 plus 2.5 plus 4 minus pi, or 9.5 minus pi. For our total distance. Okay, if I wanted displacement after 8 minutes, so that's from 0 to 8, I would add all of my areas together, but this time for displacement my negatives matter, so when I go through and add these negative 4s, they're going to stay negative. So this is negative 4 and positive 4 will cancel. Negative 4 and positive 3 is negative 1 plus 2.5 is 1.5 minus pi. So just add all of your areas together. If it's displacement, then if it's negative, we're going to keep it negative. Okay, if this is velocity and I want to get to acceleration at 6 minutes, then I'm stepping down from velocity to acceleration, which means we're going to take a derivative. We're going to drive. A derivative is the slope. So here at 6, my slope would be the slope of this blue line here. So that would be rise over run. We rose negative 4 units because we went down. So down 4 and over 2, down 4. Okay, so my slope is rise over run, or negative 4 over 2, or negative 2. Any questions on these three? Okay, I'm going to try a harder one. Okay, so I'm told that this figure that we've created here can be divided into trapezoids, semicircles, triangles, and half circles. And that for questions 1 through 9, f of x is velocity. Okay, so I'm going to split this up first into a couple different areas. Okay, so let's get the easy stuff out of the way first. I've got this rectangle here in green. What's the area of that rectangle? Well, I kind of color these in. Okay, I've got 6 units for that rectangle. How about this blue triangle I'm coloring in? Okay, I'm hearing a couple different answers here. What's my base and what's my height? Okay, so I've got a base of 1, height of 6. So I've got 3 units here for the blue one. So that's an area of negative 3 because I'm below the curve. For this green one, we have an area of negative 6. Again, because it's below the curve. For this, so this should go all the way down to the point here. So if I'm going all the way down from this point to this point for that line, then I'm going down by 6 units. It's a little bit hard to see because I've kind of made these lines really thick so that we could see them in the display. But it should be connected, so I need to go all the way down to that red line. Okay. Then I've got this quarter circle here, which should be how much? Okay, that one's just pi. And that one's going to stay positive since we are above the curve. Yes.
Yesterday I watched your video and you said to the one beside the yellow one said 1/3.
Yep, so that's next. So for this line here, the way that I'm going to figure out where this crosses is to shift it. So I'm going to pretend our axis is right here. And then we'll get the slope of this line. So this line went down by 6 units. So slope of 6 units in one space from here to here. Negative 6x, and it had an intercept of what would have been at 2. So if I want to figure out what my x value will be, so that's my distance from this point, if y is equal to 0, then I can solve for x. So that's 6x equals 2, or x equals 1/3. So this distance from here to here is 1/3. Okay, so I'm going to undo all that. We just proved this distance from here to the intersection point is 1/3. So that means this distance from here to here is 2/3. In that case, what would the area of this really small triangle here be in white?
So it's
Okay, what's my base?
yeah,
What's my base for this one? Okay, my base is 1/3. What's my height? 2. Okay, so this is 2 times 1/3 times 1/2, right? Or area is equal to 1/3 for this really small triangle. Okay, I'm going to shade that in the 2 while I'm here, so we'll make this pink maybe. Okay, the area of that pink one is 1/3. Okay, we can also get the area of the yellow triangle here. So this is a base of 1 2/3, or 5/3, and a height of 4. So that's an area of negative 10/3. Negative 10/3 because we are below the curve. See if I can just write with a finger. Nope. There we go. Okay, then the hard part. So I'm going to box this in again. For this box here, the area of the whole box is 4. So area of box is 4. The area of this quarter circle is pi. So what should the area of this green part be? 4 minus pi. And it is negative. So that's negative 4 minus pi is the area of this green space. Or if you wanted to, you could say this is pi minus 4. Okay, then this blue space I'm going to split into 2. So I've got negative 8 units on top. And then this is the same circle, so same radius, but we've got 2 of them now. So this is 2 pi, and it's negative because it's on the it's below the 0. So this is negative 8 minus 2 pi for this total area. Okay, any questions on our areas? Okay. So for questions 1 through 9, this graph represents velocity. The first thing I want to know is what was the speed 2 seconds before starting? Okay, I'm going to go back to my table. You can see in order to get from speed to from velocity to speed, I am not deriving and I'm not integrating. I'm just going sideways. Anytime you go sideways, you'll need to take an absolute value. Speed is velocity without direction, so if it's negative, it would be positive. So here I am at 2 seconds before or after, 2 seconds before we started. Okay, so 2 seconds before we started. My speed is up here, actually. So that would be 2. And we don't have any units, so I'm going to leave it like that. If I had wanted the speed, we'll say 2 seconds after we started, that would also be positive 2, because speed is the absolute value of our velocity. So right now if our y value is velocity, and then our velocity 2 seconds after we started is negative 2, our speed would be positive 2. Okay, if I want acceleration 5 seconds before we started, so here's 1, 2, 3, 4, 5 seconds before we started. Oh. That's a bad one I didn't fix from yesterday either. I'm going to do 4.5 seconds before we started. Okay, so 4.5 seconds before I started, I am on this line. If I've got velocity for my y value and I want to get acceleration, then what do I have to do? Do I have to derive or do I have to integrate? Okay, right now this graph is velocity. If I want to get to acceleration, do I have to derive or integrate? Derive, okay. So 4.5 seconds before starting, we are on this black line here. Okay, so if I'm on this black line, then how can I derive? How can I get the slope? This line here in black. What's the derivative at 4.5 seconds before we started? So right here in the middle. What's the slope? Okay, 6 is the slope, you're right. For all of the points on the line, the slope is the same. Since the derivative is a slope, we can just take the slope of the line. Okay, displacement 6 seconds before starting. So this is how far away from the start point were we 6 seconds before we started. Okay, this is a little bit interesting because I'm actually working backwards. So from where we started, if I went backwards by negative 10 thirds units, then I would actually be adding 10 thirds units. So this is 0 minus 10 thirds, minus 1/3, minus pi, minus negative 3, minus negative 6. Okay, it gives me 9 thirds plus 9, or 12 minus pi. For our displacement. If I wanted total distance traveled 6 seconds after starting. Total distance traveled, will my direction matter or not matter? Okay, for total distance traveled, our direction will not matter. So if direction is important, then you'll see displacement. If direction is not important, you'll see total distance traveled. So if direction is not important, then we don't care about these negative signs. So that means in order to get from velocity to distance, we're still taking an area. So this will be 4 minus pi plus 8 plus 2 pi. Okay, so I got rid of all of the negative signs. The reason why the negative pi is still there is because that negative pi is actually cutting out the white space. So even if I add the green space area, I'll still be adding 4 minus pi. Okay, last 4. So if f of x is velocity, I wanted to find the integral from negative 6 to 6 of f of x. Okay, so if I'm just integrating, that means I'm not taking any absolute values, but I'm adding the areas. So would that be displacement or total distance traveled? Okay, I'm going to zoom in here. F of x is velocity. If we just integrate f of x, will the displacement, okay. If we're just integrating, that means the negative signs are still negative. If we're leaving the negative signs negative and getting the area, then we're stepping up, but we're not stepping sideways. So this will go from velocity to displacement. Okay, so starting at negative 6 and going to positive 6, I'm going to add all these areas together. Okay, so this one would be negative 6 minus 3 plus pi plus 1/3 minus 10/3 minus all of 4 minus pi minus 8 minus 2 pi. And then we add all of that together. Okay, so I've got negative 6 minus 3 is negative 9. The negative 10/3 plus 1/3 is negative 9/3, which is negative 3, so that's negative 12. Minus 4 is negative 16. Minus 8 is negative 24. Okay, then I've got all my pi's. So this is positive pi plus pi, because I distribute that negative, is 2 pi. Minus 2 pi cancels. So my total displacement, which is the integral from negative 6 to 6 of my velocity, would be negative 24. From where we were at time negative 6 to where we were at time positive 6, we moved backwards by 24 units. Okay, so we said number 5 represented displacement. If I wanted to change question 5 so that this would represent distance instead, then instead of integrating just from negative 6 to 6, I would have to integrate from negative 6 to 6 of the absolute value of f of x. Which means I would take all of the negative areas and make them positive. If I do that, then we're looking at total distance that we traveled, sort of like the odometer on a car, instead of how far you are away from the start point, which is displacement. Okay, so units would still be meters. Or kilometers or miles or any other units for distance. Okay, if f of x is velocity, find the derivative when x is 4. Okay, so I'm going to go jump back up here. Here's t equals 1, 2, 3. 1, 2, 3, 4. Okay, so we're right here. At this point, what's our derivative of the red line?
Which red line? There are several.
Okay, so we're right here for our point. I want to know what the slope of this point is. At x equals 4.
0.
0, perfect. This is a minimum value. Every minimum or maximum value, every relative minimum or maximum will have a slope of 0. So my derivative at 4 is 0. And what would this represent? So if our original graph was velocity, what is the derivative? Acceleration. Okay. We're a little bit over time for what I was looking for. So I'm going to look at the next questions and we'll just talk about how we would solve them instead of actually solving them. If our y value was actually acceleration, how would I get the velocity? Okay, okay, I would have to integrate. If the velocity at t equals 0 was already 4 meters per second, then our velocity at 4 seconds would be the 4 that we started with, plus the integral from t equals 0 to t equals 4 of f of x. So I'd take all the areas that we have from 0 to 4, and I would also have to add the 4 meters per second that we started with already at t equals 0. Okay, if f of x is acceleration, how would I find the speed? So how could I change this to find speed? What's the difference between speed and velocity? Direction doesn't matter, so absolute value, perfect. So the math is exactly the same, only we're taking the absolute value of our final answer. I think maybe because part of that's not an equation. There we go. So I'd take the absolute value of our start point, which was already 4 meters per second for velocity. So we started with some speed already. And then I would add how much our velocity changed, which would be my acceleration, that's meters per second squared, times my x-axis, which is in seconds, would tell me my meters per second of change from time 0 to time 4. Okay. If my y value was displacement, how could I get to velocity? Derive. Okay, so I'd be looking for the slope between 0 and 2 seconds. If my y value is displacement, how could I get to acceleration? Perfect. Derive twice. All right. Any questions on what we did? Okay. So this is really more of a conceptual unit. I just want to make sure that we're okay with the units and what's actually going on with our integrals and derivatives before we move on. Which is why all of these areas are semicircles, triangles, or trapezoids. But you will see questions like this on the AP Calculus exam if you keep going. Again, if they're just trying to test concepts, then they don't want the areas to be a problem. Okay, so for homework, I have a sheet that I've just sent on WeChat. called Graphical Integration and Trig Functions, Part 2. Um, I need you to complete that by Thursday at 9 a.m.
How many questions is there?
There are 12 questions,
Oh, okay.
so it shouldn't take too long. But okay, and if you guys have questions, please hit me up on WeChat. Any other questions before we break?
No,
Okay, thank you very much for coming. Sorry it was so long today.